I don't know about you guys, but I've literally been waiting all day to review functions. Why? Because they're so fun. Let's start. That couldn't have been more monotone. Anyway, first question. It says, write the linear function that has the indicated function values. So we've got f of 2/3 equals negative 15/2 and f of negative 4 equals negative 11. Okay, we need to write the equation of a line. What things do we need in order to write the equation of a line? Very good. Slope and a point. That's the only thing we need. So here's 2 points. Can we write the slope from these 2 points? Yeah. All right, put me on pause. At minimum, you can calculate the slope on your own. Go ahead. All right, hope you had as much fun as I did. So I've just started by writing the ordered pairs for this function notation, just in case anybody was a little bit confused with what I was saying earlier. But first thing I did was I found the slope, and I hope you guys did too. The slope is 3/4. And actually, I wrote our answer in 3 possible ways. I wrote it 2 times in point slope form using both ordered pairs, or I also found slope intercept form as well. So any of these 3 would be acceptable. Next, find the coordinates on the graph of a function f if the given point is on the graph and the function is even or odd. So here are the ordered pairs. Just as a quick review for you. Remember, if a function's even, think about its symmetry, right? We know it's symmetric with respect to the y-axis. So we know that f of x is equal to f of negative x. And then recall that if a function is odd, then it's symmetric with respect to the origin. So we would know that f of x is equal to negative f of negative x, which, by the way, is the same thing as negative f of x equaling f of negative x. You could see that both ways. These are equal, right? So using this information, let's see if you guys can come up with these ordered pairs. Go ahead. All right, so for part A, even, notice that I changed the x values in both of the ordered pairs, didn't change the y value. For odd, I changed both x and y. Moving on, evaluate. Evaluate f of negative 2, f of 0, and f of 1. Keep in mind, since this is a piecewise function, you have to consider its restricted domain. So where would I need to plug in negative 2, which part of the function? Go ahead, put me on pause, and let's check after. Alrighty. Well, negative 2 falls within x is less than or equal to 0. So we should plug it in here. 0 would fall into the first one because it's less than or equal to. And then 1, of course, is greater than 0. So you should get 1, 5, and 1. Find the relative extrema in the increasing and decreasing intervals of the following function. I would love and ask you to do this using your graphing calculator. Use those special features. Okay? Go ahead and find those, and then we'll check shortly. All right, you guys, so I asked you guys to use your graphing calculators for this. If you are a little bit rusty on your graphing calculator skills to find extrema, I would definitely recommend going back to your 1.2 videos or asking class. Ask a classmate, ask me. But here are the ordered pairs for the relative min and relative max. Got some funky numbers here. And then we have our increasing and decreasing interval. Next. The height y in feet of a baseball thrown by a child is given by the equation below, where x is the horizontal distance in feet from where the ball was thrown. Will the ball fly over the glove of another child 30 feet away, trying to catch the ball at 5 feet above the ground? And here's our equation. So this is a yes or no question. Okay? I want you guys to think about this. I know sometimes word problems are scary to us, but you guys can do this. Think about, where's this 30, where's this 5 going to go? How are we going to use those? And how does this equation represent the scenario? Think about that, and we're going to check in a second. Okay, so let's think about what x represents. X represents the horizontal distance in feet from where the ball was thrown. So we're trying to see how high the ball is going to be once it's thrown 30 feet away, right? Will it clear 5 feet? Will it not? That's the question. So what I did is I plugged in 30 in for x to represent the horizontal distance, and I found that once that ball is thrown 30 feet, its height is going to be 6 feet. So is that above 5 feet? Yeah. So yes, the ball will fly over the glove. Really important word problems, we always have to answer within the context of the problem. All right, next, we got a piecewise function here. We would like to graph it. Then we're going to state the domain, range, increasing, decreasing, and constant intervals. This is a lot in one. This is fun. Go ahead. Okay, humans, here we go. I started with the graph. I tried to color coordinate here just to show you guys the pieces. The one part that I really want to make sure that you guys notice is that even though when f of x is 1, and I know that it has an open circle at 3 for that piece of that segment, well, technically, this last piece here fills that spot because if I were to plug in 3, boom, that would be 1. So just letting you guys know. Our domain, -infinity to 5, including 5. Range, -1 to infinity. We have our increasing interval from 3 to 5, decreasing -infinity to 1, and constant from 1 to 3. Find all the real zeros and find the domain. Go ahead, put me on pause. Can't wait to see how you did. All right, you guys, so lots of factoring going on here. I factored the numerator, I factored the denominator as much as I could, and I kind of got to this point. In terms of finding the real zeros, right, what values of x makes this 0, I really only need to evaluate where the numerator will be 0. Because we know that wherever the denominator is 0, that's actually undefined. That's not a 0, not an x-intercept. So I went through, I set both of these factors equal to 0 themselves. In this case, I got plus or minus square root of 5, so I got 2 real zeros here. And I know that when I take the square root of -2, I'm going to get an imaginary 0, and it specifically said real only. So, boom, done with that. Domain. So domain would be defined values of x. So it's kind of more helpful to figure out what values of x are undefined. So set the denominator factors equal to 0. In this particular case, I'll get another imaginary 0, so not helpful. But here I get that 1 is the one value of x that's going to make this undefined. So my domain is not x equals 1. It's actually everything but that. My domain is -infinity to 1, union 1 to infinity. Okay. State the domain in range and interval notation. You can do this. Put me on pause, then let's check. All right, check your answers here. Hopefully I didn't make any mistakes. Our domain's -infinity to -5, union 1 to infinity. Range is -infinity to -4, union -2 to infinity. Check the brackets, check the parentheses. Next, is the following function even, odd, or neither? Think about the tests that you need to do for even or odd. We did something similar previously. Go ahead, put me on pause. All right, so for the even test, I needed to check, is f of x equal to f of -x? Plug it in, does not produce the same as the original, not even. Odd, I need to check if f of x is equal to -f of -x. So I actually already did f of -x over here. Then I divided everything by -1. Does not produce the same. Not odd. Therefore, neither. Oops. Stupid pen. Next. All right. Are there any directions on here? Okay. Draw y using the indicated transformation of f of x. So that's f of x in blue, and you want to do these transformations to it. Go ahead and graph that. All right, first I think it's important to know what are the transformations here. First things first, absolute value. Make all the y values positive. Then vertical shrink by 1/2. Cut all the y values in half. Then shift down to units. The points that I did these for included any of like the, I guess you could call corner pieces, as well as any x-intercepts. Okay, that's how I'm going to ensure, especially with this absolute value here, that I'm going to hit every point that could potentially cause a turn. And that's it.